Hello, welcome back. In this video, we're going to learn about interfaces. Interface is another concept like abstract classes. But before we learn interface, there's one more thing to cover in inheritance that will really help to understand where and why interfaces become very helpful. So if I were to create a new class, you don't have to create it. You can just, follow along. Um, I'm going to say some weird shape, hit finish, and I try to extend multiple classes. So if I say extends circle and shape, Java does not even recognize it, right? It's a syntax error. What I'm trying to say is you cannot extend multiple classes. In object-oriented concepts, it's called multiple inheritance. So there are other programming languages, object-oriented programming languages that support multiple inheritance. Java doesn't because we talked about, methods being overridden in subclasses, but one of the main concerns is if you have a class extending two other classes and both of them have concrete implementations of a method, then when you invoke the method on an object of this child class, the language may not know which method to call, right? So which superclass takes precedence. It's kind of hard to define that. So in Java, that multiple inheritance concept itself is not supported. In other words, you can always extend one and only one class. You cannot extend more than one class. But there may be situations where you may want to have multiple abstract classes, right? Defining abstract methods that you would want to override in a subclass. To solve that, and for other reasons, Java has a concept called interface. So I'm going to delete this. I'm going to delete this class because we don't need it anymore. I'm going to create a new interface. So we have used only class so far. We're going to create a new interface now. And I'm going to again create shape interface. Actually, I'm going to create shape, but in a new package. So I'm going to say section 1 dot pkg2. Finish. I named it wrong. Darn. So instead of doing that, I can just say right click. It'll be good to understand this. So if you do a right click and go to refactor, you can do a rename. So this is much better than renaming the class yourself because Java will update all the references of the type you're updating. So this is a much safer way to rename something compared to you doing it manually. So if you right now we don't have anywhere it's used, but let's say if this interface is used elsewhere, Eclipse will update all the references automatically. So hit finish. Now even the name is changed here. That's good. So we're going to define an interface shape because if I go back to the shape abstract class, we had some methods defined, like concrete methods defined, and some abstract, right? But what if there is a scenario where you need to define something like an abstract class, but you cannot define any of the methods? You just want to create the signatures. So these are called signatures. You just want to create the method signatures. You don't know what to implement, right? You There is nothing to be implemented in these methods. In those cases, you can create an interface and say, again, here we can create public double calculate area. So all the methods in an interface should be public and you cannot create any data members. If you say private int num, you're going to get an error and it says illegal modifier for the interface field shape num. Only public, static, and final are permitted. So anything that you define in an interface should be public, static, final. So all the fields should be public, static, final. If I say public, I still get the error. If I say static, still have the error. Final, let's see what it says now. The blank final field may not have been initialized, and you need to initialize. So when you initialize it, what does it look like? It's a constant. So The only things that you can define in an interface with respect to fields are constants. You cannot define anything else. So that's important to remember. I'll leave it here. This is not going to be useful for us. I'm just going to leave it here. But since this is a constant, you're going to have to make it all capitals. That's the best practice we talked about earlier. Now we have a method. Again, the method cannot be anything other than public. So if I say private double, I'm going to get an error. So only public is permitted. So what we have defined here is an interface and say this interface has one method that is public double calculate area, right? We're not giving any definition. You cannot also give any body to it. If you say this, you're going to get an error as well. Abstract methods do not specify a body. Note that we did not say abstract. We did not type abstract here. That's because all the method signatures that you create here are by default abstract because you cannot give a body. So that's interface. Interface basically helps you create um, not a blueprint, but basically a structure. It's going to force anybody that is implementing this interface to actually provide a body to the method. Same way like abstract classes. If you inherit an abstract class, you have to override the abstract methods. Similarly, if you implement, I say implement because when you add this to a class, you're going to say implements. Let's go ahead and create a new square class now. You're going to say square, and in this section, you can actually add interfaces. So let's go add shape. You can actually select it. So let's select shape, hit OK, and then hit finish. So as you can see, public class square implements shape. So in case of inheritance, class inheritance, we'll say extend. In the case of adding an interface, we have to type implements. That's the keyword. So when you say a class implements a shape, that means the class is going to give concrete implementations of the methods that the interface defined. So in this case, we have calculate area. So I'm going to close this abstract class so it's not confusing. So we're just talking about this interface we just created, which is being implemented by this class. And we are overriding the method that we are supposed to override. So in here, since it's square, you can say double, it's double, which is private, sorry, should be private double side, right, our length. And we can add our constructor, so public square double length is this dot length, it's called length. And we can add our getters and setters as well. We're going to right click, go to source, generate getters and setters for length, and OK. So we have successfully implemented an interface. And same way we can create a main method and then calculate the area. Let's calculate the area as well. Double area equals length into length, and then return area. So we have that implemented. We can obviously create a main method and then call the calculate area on the object for square, which we know. One more thing to understand about interfaces is we talked about how we cannot extend multiple classes. You can inherit only one and only one class. But in the case of interface, you can implement as many interfaces as you want. For example, I can create another interface and call it something like position, finish, and then say public void um, something like display position. So that's going to be our abstract method inside the interface. And then I can go back to square and then say implements shape, comma, position, just like that. So now the class is implementing two interfaces. We have an error here because if you go here, it'll say the type square must implement the inherited abstract method display position because this interface has that as abstract. So when you click this guy to create the method, the error goes away. So this is how in Java you can implement multiple interfaces and give concrete implementations for those abstract methods in the subclass or in this class. And in Java, that's how you kind of achieve multiple inheritance. You're not inheriting a class, but you are implementing multiple interfaces. So you could have different signatures and different interfaces, and you can implement that in a child class and give concrete method bodies for that. So that's basically interfaces. Interfaces help set a standard, right? Say whenever you create any shape, square or something, if you implement this interface will tell you what are the methods you need to implement, and it's going to force you to implement it because otherwise that class will not be a concrete class. So that's basically interfaces. Interfaces are again very widely used. One of the best practices is to create an interface to kind of like dictate what are the methods that need to be implemented when that interface is actually implemented in a class. So I hope this video was clear. I would really like to encourage you to create at least another interface and then try to implement that in a concrete class, see how it behaves. But that's basically it. Thanks for watching. See you in the next video.